Again, welcome to Inferential Statistics in Decision Making. This lecture has covered the introduction to hypothesis testing. Our main objective is to go through the steps in performing hypothesis testing. So, for example, we are going to learn how to state the null hypothesis and the alternative hypothesis. We're also going to learn how to identify type 1 and also type 2 errors. And also we are going to learn how to determine whether to use one-tail or two-tail stat tests and how to find the p-value. So hypothesis testing is a process that uses sample statistics to test a claim about the value of a population parameters. So we can say that hypothesis testing is an inferential statistics. In this case, we are going to use a sample statistics to test a claim about the value of a population parameters. So, for example, an automobile manufacturer advertised that its new hybrid car has a mean mileage of 50 miles per gallon. Now, to test this claim, we need to collect a sample. Now, if the sample mean differs enough from the advertising mean, then we can decide that the advertisement is wrong. And the next thing we should know is what is a stat hypothesis. The stat hypothesis will be the statement or claim about a population parameter. And we need a pair of hypotheses. One that represents the claim, which will be the null hypothesis, and the other that complement it. So that will be the alternative hypothesis. So when one of these hypotheses is false, the other must be true. So first is the null hypothesis. So that will be our claim. Here we say a stat hypothesis that contains a statement of equality, such as less than or equal or greater than or equal. And it's normally denoted by HO, which is read as a H sub 0 or H naught. Now, the next one will be the alternative hypothesis. So alternative hypothesis always will go against null hypothesis. Again, null hypothesis is our claim. So alternative hypothesis can have a statement of inequality, such as greater, not equal, or less than. And it must be true if HO is false. And also we normally use the symbol HA, or we can read it as H sub A. Now here we said the two, which is the null hypothesis and alternative hypothesis, is a complementary statement. If null hypothesis is true, then alternative will be false. If alternative statement is true, then null hypothesis will be false. Now, to write the null and also the alternative hypothesis, we need to translate the claim made about the population parameter from a verbal statement to, again, a mathematical statement. Now, we need to complement it. So, for example, here we say that if HO is the mean is less than or equal to K, then HA, the mean, will be greater than K. Here we are using mean, which is the population mean. So if we have a statement saying that the population mean is less than or equal to K for the null hypothesis, then the alternative hypothesis will be the mu or the population mean is greater than K. So when one is true, the other will be false. Another example here, if the mu is greater than or equal to K, then alternative hypothesis, the mu will be less than K. Or if the mu is equal to K, then HA will be not equal to K. And normally, if mu is equal to K and HA, the mu not equal to K, this we normally call this the two-way test. Now, regardless of which pair of hypotheses you use, you always assuming that the mu equal to k, and also examine the sampling distribution on the basis of this assumption. So we have one example here. Here they say, write a claim as a mathematical sentences. State the null and also the alternative hypothesis and identify which represent the claim. Here we say a university publicized that the proportion of its students who graduate in 4 years is 82%. So this will be again the claim. So HO will be the P equal to 82%. Again, 82% is the same as 0.82. Now, since the HO or the null hypothesis is equal, then HA should be not equal. So that is the complement of HO. We cannot say that if P equal to 0.82, then in HA, the P should be greater or less than 0.82. We cannot say that. Now let's look at the next example. Here we say a water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons per minute. So this will be our claim. So again, since we said the mean flow rate of certain type of faucet is less than 2.5 gallons per minute, our HA will be the mu is less than 2.5 gallons per minute, and because it's inequality condition. Remember, H will have to be equality either greater than or equal, less than or equal. So in this case, our answer will be greater than or equal, because if we have less, then we should have greater or equal. So that would be the HOs. Always again, HO and HA, they are complement to each other. Now, another example here said a cereal company advertises that the mean weight of a content of its 20-ounce size cereal boxes is more than 20 ounces. So it's more than 20 ounces. That will be again, the HA will be, the mu is greater than 20 ounces. So it means the HO will be less than or equal 20 ounces. Now, we have two types of errors in a hypothesis testing. And the whole concept of the error is that what is the chance that we are going to reject a true HO, or we are going to accept a false HO. So those are the two types of errors. We call them type 1 and type 2 errors. So yes, we say no matter which hypothesis represent the claim, always begin the hypothesis test assuming that the equality condition in the null hypothesis is true. Always. But at the end of the test, one of the two decisions will be made. Either we are going to reject the null hypothesis, or we are going to fail to reject the null hypothesis. Now, when we reject the null hypothesis, it means the alternative hypothesis is correct, true. But again, in statistics, we don't use that term because the alternative hypothesis, we find it by using a sample. So always either we reject or accept the null hypothesis. So we cannot say, instead of saying reject the null hypothesis, I'm going to say I accept the alternative hypothesis. We normally don't say that. Now, because your decision is based on a sample, there is the possibility of making the wrong decision. Actually, this is the reason why we don't use alternative in our statement that reject or accept alternative, because we are using sample. Now, types of errors, we said there are two types. Our first error, type 1 error, means we reject the true HO. So HO is true, but we reject it. And type 2 error will be, we do not reject a false HO. So again, type 1 error means the chance that we are going to reject a true HO. And type 2 error is the chance that we are not going to reject a false HO. A false HO is supposed to be rejected. So if we do not reject it, then we have type 2 error. So here we say type 1 error occurs if the null hypothesis is rejected when it is true. And type 2 error occurs if the null hypothesis is not rejected when it is false. So let's see an example. Here they say the USDA limit for salmonella contamination for the chicken is 20%. A meat inspector reports that the chicken produced by a company exceed the USDA limit. You perform hypothesis testing to determine whether the meat inspector's claim is true. So when will a type 1 or type 2 error occur, which is more serious? So here we say that again. First of all, let's get our HO and HA statement. So we let the P represent the proportion of the chicken that is contaminated. And we remember they say greater than 20%. So P will be greater than 20%. Then HO will be less than or equal to 0.2, which is 20% also. Now, chicken meets USDA limit. HOP is less than or equal to 0.20. Then if the chicken exceeds the USDA limit, is when we have P is greater than 0.20. That's for the null hypothesis. So we have our hypothesis that HO, the null hypothesis, P is less than or equal to 0.2, and HA, P is greater than 0.2, which is the claim. Now, type 1 error is when we reject HO, when it's actually true. And normally here we say the actual proportion of the contaminated chicken is less than or equal to 0.2, but we decided to reject HO. Then type 2 error is normally occur when we fail to reject a false HO. So here we say the actual proportion of contaminated chicken is greater than 0.2, but we do not reject HO. So that would be type 2 error. So type 1 error is when we are rejecting HO, when the HO is true. And type 2 error is when we fail to reject a false HO. So again, that's the claim. P is greater than 0.2. Then HO will be P is less than or equal to 0.2. Now here we say with a type 1 error, you might create a health scaring and hurt the cells of chicken producers who were actually meeting the USDA limit. Because remember, type 1 error, we refuse to reject HO when it's, type 1 error is when we reject HO when it's true. Type 2 error means we refuse or fail to reject HO when it is false. So with type 1 error, you might create a health scaring and also hurt the cells of chicken producers who were actually meeting the USDA. Now with the type 2 error, you could be allowing a chicken that exceeded the USDA contamination limit to be sold to the consumers because greater than. So this means a type 2 error could result in sickness or even death, because here we refuse or we didn't reject a false HO. So that would be more dangerous. Type 2 error is failing to reject HO when it's false. And type 1 error is rejecting. So if you are rejecting something, whether it's good or bad, it doesn't have much effect. But when you're accepting something and it's bad, then it has effect on a bad effect. So again, type 2 error could result in sickness or even death because we fail again to reject the false HO. Now, next is the level of significance. Here, the level of significance, normally here we say your maximum allowable probability of making a type 1 error. So always we use the alpha equal to 0.05. It means that's the most maximum percentage, let's say 5%, the 5% chance of allowing probability of making type 1 error. That is rejecting the true HO. Normally we use the symbol alpha, lower case letter alpha. Now, by setting the level of significance at a small value, we are saying that you want the probability of rejecting true null hypothesis to be small. So commonly used level of significance are always 10%, which is 0.10, or 5%, 0.05, or 1%, 0.01. So probability of type 2 errors is always equal to the beta. Now, next is the STAT test. So after stating the null hypothesis and also the alternative hypothesis, and also we have specified the level of significance, and also we have a random sample has been taken from the population, then the sample statistics are calculated. So the statistics that is compared with a parameter in null hypothesis is called a test statistic. So here we have a population parameter and also the test statistics. Population parameter, the mean is mu, and for the sample it will be S bar. Then we also have the proportion P, and the test statistics we have a P and caret. Then standard deviation, or in this case is the variance, it will be sigma square. For the sample variance, it will be S square. Now the p-value or the probability value, here we say if the null hypothesis is true of obtaining a sample static with a value as extreme or more extreme than one determined from the sample data. Now it depends on the nature of the test for the p-value. Now we have three types of hypothesis testing: the left tail test, right tail test, and also the two-way test. So the type of test, again, always depends on the region of the sampling distribution that favors a rejection of null hypothesis. Now, this region is indicated by the alternative hypothesis. Now, the left tail test, here we say that the HO will be, mu will be greater than or equal to K, then HA, the mu will be less than K. So again, the left tail test is when the HA or the alternative hypothesis contains the less than inequality symbol. And it will look something like this: a normal distribution. This is a parametric test, so our distribution will be normal, and we can see the left test, the left region. Now with the right tail test, the alternative hypothesis HA contains the greater than inequality symbol. So HA will be the mu greater than K, which means the null hypothesis or the HO will be less than or equal to K. So it will look a normal distribution to our right. So the blue area normally will be the area that we are going to reject, the HO. Then the brown area we are going to accept, again, the HO. Then we have the two-tailed test, which means the HO, the mu equal to K, and HA, the mu not equal to K. So it goes to both sides, left and right. So P is always twice the area to the left of the negative test. And also here, P is twice the area to the right of the positive test statistic. Now, let's see one example here. They say here, for each claim, we should state our HO and HA. Then we are going to determine whether the hypothesis testing is a left tail, right tail, or two-tail test. We need to sketch a normal sampling distribution and shaded the area for the p-value. Here we have a university that publicized that the proportion of its students who graduated in 4 years is 82%. So that will be our HO is P equal to 0.82. So HA, P will be not equal to 0.82. So we have a two-tail test. Now, equal to 0.82 is based on the condition in the question, because the question says university publicized that the proportion of its students who graduated in 4 years is 82%. So this will be our normal bell-shaped curve. Now, the next, we have a water faucet manufacturer announces that the mean flow rate of certain type of faucet is less than 2.5 gallons per minute. Now, here we say it's less than, so that will be the HA. So the mean will be less than 2.5. Then HO will be greater than or equal to 2.5. So this will be again less than, so it will be left tail test. Next, we have a cereal company advertised that the mean weight of the content of its 20-ounce size cereal boxes is more than 20 ounces. So this will be right tail. So HA will be greater than 20 ounce. Then HO, the mean will be less than or equal to 20 ounce. So we have a right tail test. Now the next section, which is making a decision. So normally in hypothesis testing, we start with stating the HO and HA. We find the test statistics. We should know the alpha value. Then we can find again the critical value. Then from there, now we are on making the decision. We find the p-value. Actually, when we find the test statistics, our main goal is the value we get. We are going to use it to find the p-value using the table in our course textbook. Now, it depends if we are doing t-test, it's a different table. If we are doing the z-test, it will be standard normal table, etc. So comparing the p-value with the alpha, now here we say that if p is less than or equal to alpha, then we are going to reject the HO. But if p is greater than alpha, then we are going to fail to reject HO or to accept HO. So we have a 2x2 table here. HO, reject HO, the claim is HO. So here we say there's enough evidence to reject the claim. Fail to reject HO, so there's not enough evidence to reject the claim. And there's enough evidence to support the claim. Since HO is saying rejecting the claim, then HA will be supporting. Then there's not enough evidence to support the claim, because again, here we say there's not enough evidence. Yeah. So another example here to interpret a decision. And here they say you perform hypothesis testing for the following claim. How should you interpret your decision if you reject HO or if you fail to reject HO? Now, HO is the claim. So here we say a university publicized that the proportion of its students who graduated in 4 years is 82%. So the claim here is represented by HO. And if you reject HO, you should conclude that there is sufficient evidence to indicate that the university claim is false. And now, if you fail to reject HO, then we are going to say that there is insufficient evidence to indicate that the university's claim of a 4-year graduation rate is 82%, and this is false. Now, here we have next question saying that you perform a hypothesis testing for the following claim. How should you interpret your decision if you reject HO, and also if you fail to reject HO? So consumer rate report says that the mean stopping distance on a dry surface for Honda Civic is less than 136 feet. But again, in this case, we don't have any other data. But the claim again will represent by HA. So HO is the mean stopping distance. Here again, from the question, is greater than or equal to 136 feet. Now, if you reject HO, you should conclude that, again, there is enough evidence to support consumer reports. And this would be a claim that the stopping distance for Honda Civic, again, is less than 136 feet. And now, if you fail to reject HO, then we should conclude that there is not enough evidence to support consumer reports claim that the stopping distance for Honda Civic is less than 136 feet. So next is the steps for hypothesis testing. First, again, we are going to state the claim mathematically and also verbally. Then we identify the null and also the alternative hypothesis. Then second, we are going to specify the level of significance, which is alpha. Normally, alpha value is always given to us. Then next, we have to determine the standard sample distribution and draw a graph. Then we need to calculate the test statistics and its standardized value, and we are going to add it to our sketch here. Now, next we are going to find so this again will be the test statistics by its critical value using the table. Then the next step, we are going to find the p-value. Then we use the following decision rule. If the p-value is less than or equal to level of significance, then we are going to fail to reject HO. Otherwise, we reject HO if it's yes. Now, next, they say we should write a statement to interpret the decision in the context of the original claim. Now, in these lectures, again, we went through the basic concept in hypothesis testing process, which, again, introduction to hypothesis testing process. We learn how to state our null hypothesis and the meaning of it. Also, what is alternative hypothesis. We also learn about type 1 and 2 errors and how to interpret them, especially with the level of significance. We also learn how to determine whether to use 1, 2, and two-tail start test and find a p-value. Or we can again write a claim for hypothesis testing. So that will be the conclusion for these lectures, and again, see you in our next lectures.